beginning chapter 8, and we're going to be talking about imaginary numbers. Yay, kind of like imaginary friends, okay, that we all have. Well, there are also imaginary numbers. Even in your imaginary world, there's imaginary math. You can't get away from math. It just constantly haunts you. But what's interesting is once we grasp this concept and use it, it's actually really easy. Okay, as long as we follow some rules and you resort back to specific information that we have in our chapter, if you flip back to those pages, mark it, and I'll tell you when to do that, it's going to be very helpful. And whenever you come across certain situations, go back to that and it will help you out. It will actually use some of the stuff that we've already learned in the past, but getting through all this shouldn't be difficult. With that being said, if you have difficulty with it, don't feel bad. Just contact me and we will work through it. Sound like a plan? Awesome. So we're going to start with section 8.1. 8.1. Now, I want everybody to read with me down at the bottom of page 316. Okay, since the square root of a negative number is not a real number, it is designated by the term imaginary. Okay, so what happens is if you try to calculate the square root of some negative number, okay, it won't work. There is no square root of negative 3. There are not two numbers that when multiplied together give you a negative 3. Anybody want to help explain why that is? What must you have, whenever you have two numbers, what must at least one of them, well, what can only one of them be whenever you multiply them together in order to get a negative number?
A negative.
A negative. So, because you're multiplying a negative times a positive in order to get to a negative. Well, when that happens, those are two completely different numbers. They can have the same digit. Okay, so 1.5 times 1.5, well, that's not 3, is it? Or is it? Maybe when you add them together it's 3, but when you multiply them it might be different. But anyway, so whenever you have two numbers that when multiplied together give you 3, in order to get a negative 3, one of those has to be negative. So if we put them on the number line, one's over here, one's over here. Both are opposite sides of the 0, so they are not the same number. So this is not, there's no real number, you can't calculate this. Alright? So it's considered an imaginary number. However, even though we have imaginary numbers, doesn't mean we can't use them or have them help us find some sort of resolution. Okay, we can still use it whenever we have to figure out something. And that's what we're going to be doing with this chapter. We're going to take a completely imaginary number that can't be calculated and we're going to figure out ways to use it. Okay? So, with that being said, look on page 317 and you are going to see a list of imaginary, well, let me ask you this. Okay. They're doing that. I'm just glad y'all hear it too. Because then I need to seek some help. So with everything that we're talking about, we have used variables or letters to help us understand things and section it off into terms. Well, whenever we talk about imaginary numbers, we're going to use the lowercase I. The lowercase I. Just like we've used X and Y and Z and A and B, which we're going to be using some of those still. But I is going to mean an imaginary number. Okay? Ought to be pretty easy to remember. Now, on page 317, we're going to look at the imaginary numbers I at different powers. Okay, so what we're going to do is follow these examples And I would earmark this page or put a tab over here or something so you can constantly refer to this page as you go along and start doing your homework assignments. It's going to be very, very useful. Now, what we're going to look at first is I being an imaginary number equals the square root of -1. Okay, which in turn equals I. Now, when we have an imaginary number squared, what that means is we are actually multiplying -1 times -1. Well, let me clarify. The square root of -1 times the square root of -1. Now, what will that give us? Somebody look on page 317. What does that give us?
-1.
A -1. Now, what's interesting, let's talk about this because you're going to see this in your homework, and I can see somebody making a mistake. So, y'all look at this, just this part right here, square root of -1 times the square root of -1. What would you think that would result in?
1.
1, right? If you think about this, we are told that if you have two numbers in a square root like this, and they're multiplied together, we can multiply those and they just stay inside. The square root of 2 times the square root of 3 is simply the square root of 6. Okay, well likewise, if you're thinking, well, square root of -1 times the square root of -1, well, I'm allowed to do that. So that should be the square root, and -1 times -1 is what? +1. Okay, and so the square root of 1 is just 1. That kind of makes sense, right? We're told that we can multiply these two together. We know that -1 times -1 is 1. So we put that under the square root. Well, 1 times 1 equals 1, so the square root of 1 is 1. The problem that we have is calculate this out with a calculator. You can get there. You can find out what the square root of 2 is, multiply it times the square root of 3, come up with the same number that is equal to the square root of 6. Now let's do the same thing with this. Plug in the square root of -1, and you're going to get nowhere. So you can't even get past this first step to multiply against this second step. So that's why this won't work. It's an imaginary number. You can't even begin this process. So don't get caught up in that. If you see where you have a negative number underneath the square root sign, then understand that you're dealing with an imaginary number automatically. Realize I've got an imaginary number, and so I'm going to have to somehow do some renaming and get that I, or I'm going to end up transitioning to a -1, and then we'll go on and see what the next ones are. So we have imaginary number cubed, which gives us what? Well, we have an imaginary number squared times an imaginary number. We know what this is here. This is -1. We know that imaginary number to the first power is just I. So now we have, anytime you have I, an imaginary number, to the third power, you will have -1 times I. Okay? So now, with that being said, if we have to the fourth power, well, that is an imaginary number squared times an imaginary number squared. This is the same thing. Well, each of these are -1 times -1, and that equals 1. Now we have I to the fifth, and we can keep going on with this, but we're going to stop at this next step because we're going to see something. So here we can have I to the third times I to the first, or I to the second, I mean, And what we will, there's actually a couple different ways that we can do this. The book shows it, we'll follow what they have first, where it's I to the fourth times I. Well, I to the fourth is 1. I is simply I. Okay, and 1 times I is I. Okay, so now, here we've gone through power of 1, power of 2, power of 3, power of 4. Well, now, once we start getting to the power of 5, it's repeating the process again, and it will just create a loop. If we go to 6, whenever we calculate it out, we're going to end up with a negative 1. 7 is going to be negative 1i, or negative I. And it just keeps flowing through. So, all you really have to worry about are the powers of 1 through 4. And whenever, if you have I to the, say it's I to the 10th, where do you think you'll be? Well, let's walk through it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will end up equaling negative 1. Simply because there's a pattern to this and it keeps repeating itself. Only 1 through 4, on the 5th one, it starts over again. Okay, does everybody understand that? Does that make sense? Anybody kind of confused by that? Yes? No? Okay. What we're going to do, keep that in the back of your mind and keep that page accessible because we're going to use these. We don't have to necessarily memorize the calculations of these from here on out. We can just know that, well, I need to figure out which power it falls under, and then I will use that answer. It makes it that much easier for us, okay? So, whenever we have, or we can look at example 1 on page 317. We have I to the power of 57. Like, what? I don't want to do that. But it's actually pretty easy, okay? Because all we're going to do, since there are 4 possible solutions out of this until it starts repeating itself, we can simply divide that power by 4. 57 divided by 4. Okay, that's going to give us 14. And then you can go through the process that it has here. Well, 14 times 4 is, where are we? Well, 1 times 4, 4. Here, we'll do this real quick. 1, 17, 4, 16 with 1 left over. So, I to the 57th power equals I to the 4th times 14, and then you have 1 left over. And I'm walking through this. Y'all really don't have to pay attention to this all that much, okay? Because past this, we're going to be moving well beyond, and I know y'all don't want to do this whole process, so that's okay. I'm walking through it just to show you that it does exist. This is one of those things that if you want to, then you can go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, until you get to 57 and find out where you land. Okay? How many want to do that? Yeah, I can kind of see that. So, which is okay, that is a step. This other method kind of helps you get there a little bit faster, kind of, okay? But it can be kind of a beat down, and just know that it's there. So what we're finding out is ultimately I to the 57th equals I. Y'all feel good about that? right? Do you feel fulfilled? Is that helpful now? So, all right. We're going to move past this. Like I said, I simply wanted to kind of show that up on the board just for the sake of showing it up on the board. What's going to be more important is this next part, because this is what we're going to be using more often throughout this entire chapter. Go to example number 2. We have the square root of negative 32. Now what we're going to do is our whole purpose in this is try to figure out how we're using those imaginary numbers. We know that this is a negative, so we know that it's an imaginary number. We can't calculate this. So every time we see something like this, we're going to rename it to help us out. We can rename this as square root of 32, positive 32, times the square root of negative 1. Because theoretically, we can multiply these two together and end up with that. Now what helps us is we can figure out the square root of 32 times, and then we can isolate this part as the imaginary number, and it creates its own term. We're going to be using the letter I. So it's almost like it's an X or a Y or an A that's going to be attached to a constant, a real number. Okay? So we can actually simplify this. This is, 16 times 2. So 16 squared is 4. We have 4 times the square root of 2 times, now let's focus on this part right here. Go back to page 317, and where in that chart do you simply see a square root of negative 1? In the first, second, third, or fourth? The first. Okay, and so what does it equal? What does a square root of negative 1 equal? I. So we rename this to I, and this is our final answer. So it can either be, you can have the dot showing that it's multiplying, or you can simply say 4 times the square root of 2I. So that is taking this number and renaming it. And so now the reason why we might want to do this is because we have to use the real number part of an imaginary number to help us get somewhere. We know it's still an imaginary number, but we need this part to help us accomplish something greater. Okay? Even if it means saving the entire world, we at least know how to do that, because sometimes we have to save the world, right? It happens. Sometimes more than once on a day, but so be it. So let's try something a little bit different. Let's go to example number 3. What's going to help you is as we start moving on, you're going to remember some of these, like as far as which one it is, the first one, second one, third, or fourth one. Well, here we know that square root of negative 1 is I. As you do this more, you're not even going to have to go back and look at the chart. So let's look at this. We have square root of negative 2 times the square root of negative 3. We can rename both of these as square root of 2 times square root of negative 1 times square root of 3 times the square root of negative 1. Now we already know that square root of negative 1 is what? I, right? So we can actually skip this whole process and look at this and see, okay, we're going to have the square root of 2 times I times the square root of 3 I. And from there, we can actually see that it's square root of 6 I, and are we done? What's wrong?
The I is supposed to be squared.
Why?
Because you're multiplying it.
Perfect. Yes, 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 very good. So just like if you had 4x times 2x, it is not 8x. Bad, 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 bad. It is actually 8x squared. Okay, so whenever we're using the variable, we're using the I the exact same way. So whenever you multiply two i's together, you get I squared. Okay? Now, what's interesting about this is we are not done. Where have we seen I squared before? Even though we just started this process, where did we see I squared? Very good, I heard some pages turn. Awesome, go back to page 317, look at I squared and see it equals what? -1. So, we'll continue this. This is square root of 6 times -1. Okay, which equals what?
Negative I.
Well,
Oh wait, never mind.
no, yeah, I see where you're going with it. Well, the square root of 6 times -1 simply equals the negative square root of 6. Okay? Because you took this, which is a positive, and multiplied it times a -1. Just like 5 times -1 equals -5. Now there's a big difference between the negative being on the outside of this and being on the inside of this. You can take the square root of 6 and then take the negative of it, of that answer. That can be calculated. Okay? But whenever it's on the inside here, you can't. So here we started off with these, and automatically we know we're going to be pulling out or separating a negative square root of 1, or square root of -1 in these processes because we're trying to get to where we have these i's. Then once we started combining together, we combine the constants, then we combine the variables, we end up with I squared, and then we can flip back again and see I squared equals -1, and we can combine it together, finding that we end up with this. All right, so with that being said, everybody get a piece of paper and pen, and y'all are going to do this. You're going to work through one on your own. Y'all do that one and see what you come up with. Actually, we're going to do one more. And just for time's sake, you don't have to simplify the square root of what you come up with. Like if, say you came up with the square root of 84, you can just leave it square root of 84 right now. I know that it can be simplified and you can draw numbers out, but just for time's sake, you can leave that part as is. If you came up with square root of 84, you're wrong, by the way. Give you just a couple more minutes to see what you'll come up with. All right, how many of you came up with an answer? Raise your hand. How many of you are confident about your answer? Raise your hand. Oh, come on, raise your hand. There you go. Even if you're wrong, at least you were wrong with confidence, right? So, all right. Well, let's work through this. We'll do it the long route just so we know that we're doing things correctly. We're not going to skip steps, even though once you keep doing this, especially as you do your homework assignment, you'll be able to identify things faster and you will actually be able to skip steps. But we're not going to on this one. So, we'll start this off. We have square root of positive 4 times square root of negative 1 times the square root of 5 times the square root of negative 1 times the square root of 2 times the square root of negative 1 times the square root of 3 times the square root of negative 1. Did everybody at least get to this part? Okay, good. All right, so what is the square root of negative 1? What can we rename that as? I. Perfect. If you didn't know that, flip back to that previous page and see it right there. If you're unsure, don't guess, especially when the book is telling you exactly what it is. So now we can replace all of these square roots of negative 1 with I. So now we have square root of 4, I, times square root of 5, I, times square root of 2, I, times the square root of 3, I. So now we can combine all the constants together. 4 times 5 is 20, times 2 is 40, times 3 is 43, right? Very good. Yes, square root of 120. Everybody get that? Yay! Pat yourselves on the back. It's a good job. So now we have I times I times I times I, which gives you I to the third, right? No, no, no. What is it? I to the fourth. Very good. Good job. See, how many of y'all are feeling more confident about your answer now? Well, good. So now all we've got to do is flip back to our page, and we see I to the fourth, and what does that equal?
1.
1. So, square root of 120 times 1 equals the square root of 120. Raise your hand if you got that answer. Okay? If you didn't get the answer, did you see where where you made your mistake?
Wait,
Yes.
so I got that, but wouldn't it be a negative, like 120 times negative 1, and then negative on the other one?
Well, why was it negative
I got
on the
the
other one?
answer.
Huh?
I was confused and tried to find it. Because on the other one it was negative 1 and this one was just 1.
Right, because it was the square root of 2, which gives us what? Negative 1. Okay, so we ended up with the square root of 6,
Oh, I get it.
I squared.
I get it.
Okay, makes sense now?
Yeah.
Because this, good, awesome. So the fourth step equals a positive 1, and so we multiply the positive 1 times what we get, and this is our answer. All right, so is this starting to make a little bit more sense now that we've done this? Cool. And with that being said, understand that this whole chapter has to do with identifying imaginary numbers and then renaming it to make our lives more simple. We're going to rename it and big focus on this thing right here. Okay? This guy is going to be helping us out. That's how they are going to help us rename some of this. All right, so let's move on. All right, we're going to talk about adding, section 8.2, adding complex numbers. Complex numbers. A complex number means that we're going to have some actual constant or number, say 4, plus, then we're going to have this, which is what we've seen in imaginary number. There's a combination. The standard form for this is A plus BI, where A is a real number and B is a real number and it cannot equal 0. B cannot equal 0. Okay, so we're going to be seeing some of this. Now, whenever, if we look at example number 1, we're going to add, there's a couple of different ways of doing this, and I'll show both, but I have a feeling pretty much everybody's going to do this one, but I'm going to show you both ways, okay? So there's 3 plus 2i plus 5 minus 4i. Okay, the first way we'll do over here on this side of the board. What we can do is we can actually, notice here we have two sets of terms that are in groups. They've grouped them with parentheses. Well, since we're adding and subtracting all the way through here, we can move those around to help us out if we want to. So technically what we could do is put the real numbers together and the imaginary numbers together in their own sets of parentheses. So we could make this 3 plus 5, paying attention to this sign right here, plus 2i minus 4i. What we can then do is add 3 and 5, we get 8, plus we have 2 minus 4, okay, and we factor out the I in this green and I. So then that gives us 8 minus a 2 minus 4, 2 minus 4 is a negative 2, so 8 minus 2i. That's one way of doing it. The way I kind of prefer, and what we've actually seen more of, is since we're adding, and there's parentheses there, do the parentheses actually have to be there? No, we can actually remove them. So we can simply say 3 plus 2i, again paying attention to this sign right here, plus 5 minus 4i. We can just take the parentheses away and then combine like terms. Okay, less parentheses, less moving around, you don't have to factor or anything like that. You simply only add the constants. It's just like if you had 2 plus 2x plus 3 plus 4x. Well, 2 plus 2 is 5, and then you can only add the x's together, so you get 6x. Same thing here, 3 plus 5 is 8, and then 2i minus 4i gives you a negative 2i. So there's really 2 steps less that you have to do to come up with the same one. Whichever one gets you there. I show you both because you may prefer this one because it may help you remember or identifying or organizing things better. If so, great, by all means use it. If not, you can use this method here. All you are doing is combining like terms. Something we've been doing all year long, even in Algebra 1 we've done this. Okay? So you have that right there, and that's your answer. Look at example number 2. This is the same thing, but what I want you to make sure of is, again, paying attention to the symbol in between. You have 5 minus 3i minus 2 plus 6i. So let's say you're going to remove the parentheses and combine like terms. You have 5 minus 3i minus 2 plus 6i. Whenever you remove these parentheses, you have to pay attention to that sign. This is telling you to take the negative or the opposite of everything that's inside here. So it'll be 5 minus 3i minus 2 plus 6i. Right? What's wrong with that?
Negative 6i.
Negative 6i, because it's not just this first term, it is both terms. Very, very good. That happens a lot. I see it a lot. It happens a lot where you just take negative 2 and then plus 6i. It has to be the negative of everything in there. If there's 8 terms inside the parentheses, then you have to change all 8 of those to the opposite, okay? So pay attention to that. And then you carry on just like what we did before. Any questions about that? That is adding complex numbers. Okay? Sounds complicated when you hear the title, but it's actually really easy. Something we've done a lot of. Okay? Now, let's go to 8.3. Multiplying complex numbers. Since adding complex numbers is the same thing as adding mathematical statements with multiple terms, mainly dealing with x, that's what we commonly use, we're going to be doing the exact same thing, only now instead of using x, we're using I, because it's an imaginary number. It's called a complex number. Why? Why is this called a complex number, as opposed to just an imaginary number? Why is this a complex number? Can somebody explain? It's really easy. You don't have to overthink it. Oh, was that a reason? Oh no, okay. So it's a complex number because we have an imaginary number, but there is also a real number being added into it. It's complex, so think about of a complex relationship that you've had. Okay? You had an easy relationship with your imaginary friend until you had a real person come along and mess up that relationship. So now your imaginary friend is really upset with you, okay, and you've got to try to control them, but then you also have to try to control your real friend, and you're being torn back and forth because you want to spend time with your imaginary friend, but you can't as much, right? And there's a problem because your real friend can't see your imaginary friend. So it's really a complex situation, right? It's complex for that reason. That's the only reason why it's being called that. All right, so multiplying. We have the example of 5 times 3 plus 2i. Here is our complex statement here. We have a real number plus an imaginary number. Here we're multiplying. Super easy. 5 times 3 is 15 plus 10. 5 times 2, which is 10i. And that's it. There's nothing extra difficult about it. No tricks or anything like that. It's that easy. If you look at the next example, on there, example number 2. You're multiplying two binomials together. Okay, 4 minus 2i times 2 plus 3i. What method do we use, do you think, to figure this out?
FOIL.
FOIL. Awesome. Same thing. Same exact thing. So we'll do our first. 4 times 2 is 8. We can do our last. Minus 2i times a positive 3i gives us a minus 6i squared. Okay, then we can do, and you can do FOIL, you can do FLIO, you can do FIOL, you can do LOIF if you want. It doesn't matter what order you do F and the I and the O and the L, just as long as you do them independently. Okay? So then we do our inners, negative 2i times positive 2, which is minus 4i. And then our outers, 4 times 3i, which is positive 12i. Now we simply combine all the like terms. There is a minus 6i squared. There aren't any other ones. Okay, we have other i's, but not to the power of 2, so we can't combine that. Okay, this stands by itself. Minus 4i plus 12i gives us a positive 8i plus 8. Just like what we've done before. Okay? Any questions so far? Okay. All right, now what's interesting about this though is we're not quite done with this. Okay, so here what we have to start doing now too is paying attention to the i's that we have. So here we have an I squared. I squared. Go back to your page and take a look and see what I squared equals. -1, okay? So now we get to actually simplify this a little bit more. So now minus 6 times a minus 1 plus 8i plus 8. Okay, negative 6 times a negative 1 gives us a positive 6. 6 plus 8 is 14. So our final answer is going to be 14 plus 8i. Notice this form is just like this up here, the standard form. So you are going to be looking to find your answers to end up in the standard form, where you have some real number plus an imaginary number, most likely having a constant attached to it. Okay? So once you get here, you get to this point, you're like, okay, I've got to get it to this standard form. Oh, hey, an I squared, I know what that is. That's -1. I remember that because I've done it like 10 times already. And so then you just combine it, add them together, and there you go. Okay, so that is really the only difference between this and if it were x's here or y's instead of the i's. You just have to take it one step further. Make sense? So standard form, standard form, standard form. Everybody do standard form. I'm going to brainwash you into remembering standard form. I'm going to keep sending you like viral emails that says standard form just to help remind you. You know, instead of the I love you email, it'll say standard form so that you know it's a virus. All right, any questions with this so far? Does anybody feel hopelessly lost right now? No, it's really, really not that hard. It kind of seemed a little bit tricky at first, but now it's all starting to make sense. Right? Cool. Go to 8.4. What's interesting too is the fact that we're going through these sections now rather quickly because we know all these methods already. It's stuff we've been using, which makes this easy. Yay! All right, now dividing. complex numbers. Dividing complex numbers. The cool thing about this section is we're not going to do that whole long division business that we've seen necessarily with those binomials in the past. Okay, we're going to do this in fraction form. Okay, we're going to do these in fraction form. So our first one is 2 plus 6i divided by, is it 3i? 3i. Okay, so now we're going to take this and we're going to rename it as 2 plus 6i divided by 3i. Because remember, in division, there are several different ways that you can express division. You can use this symbol, you can use the divided by symbol, or you can use this line. So now, what we can do is a couple different things, but what we're going to do is break this up. We have 2 over 3i plus 6i over 3i. All right. We're going to show, okay, let's pause right here on this one, okay? We're going to stop right here, and then we're going to actually also do the way that the book is showing, and then we can compare them and see what we come up with, okay? So with that being said, we'll leave this here. We'll work on what the book says up here. So what we have 2 plus 6i over 3i. Now, with all of these situations, what we want to think about is in terms of radicals. Okay, so let me ask you this. We have 2 divided by square root of 2. Do we want to do this? Can we do this? Do you remember what we did to not do this?
We erase the square root.
Okay, how? How did we get a square root? No, just simply erasing it?
Yeah.
Didn't work. Leaving that question blank, though as an option, didn't work because it resulted in an answer of an x, and that was off to the side of your question. We did get rid of this, but how did we get rid of it?
So
Okay, kind of. Go ahead.
what do you say? What did you say?
I ain't telling you. You gotta say your answer first.
Don't you have to like?
We are simply renaming it.
You just.
I love the momentum at the beginning, and then you just. I think she said something. Wait. We're going to multiply this times 1. But how are we going to multiply by 1? In what form?
Multiplication.
Yes, multiplication style. Kind of like Gangnam style, but it's multiplication style. All right, so we're going to do this. Square root of 2 over square root of 2. That equals 1. Now what happens when we multiply these two square roots together? The square roots go away. We have 2 to the square root of 2 over here, and we end up with just 2. Now this we can actually calculate. Okay? We're going to treat this the same way. Okay? We're going to treat these the same way and end up resulting in a solid number, or a real number down at the bottom. Now, what happens whenever we, or how can we multiply this times 1? In what form can we multiply this times 1? Similar to what we did here. This, what's that?
Do 3i over 3i.
That 3i? Okay, then what do you end up with? Why, let me ask you this, why the 3 with the 3i? It's not wrong at all. It's actually really good that you're thinking that way. So it's just the 3 in it is kind of unnecessary. What if we just did I over I? It's the same thing, right? It's still 1, and then you don't even have to multiply the 3 times 3. So let's do this. I over I. So now we have 2i plus 6i squared over 3i squared. Now, what is I squared equal to? How many of y'all know without looking back to page 317? -1, very good. So now we can substitute these out for -1, and we get 2i minus 6 over minus 3. And there we have it. Same type of form as this right here, if you think of it in terms of the I being a radical or a square root number. Okay, we have a real number down on the bottom, and then we can go from there. Now with this, what we can do is, this form is fine. You can actually separate these. The book explains how you split this up into 2 separate fractions. 2i over -3, and then -6 over -3, which is just -2. Both are correct answers. Okay, both are correct answers, but you can leave it in this form. Now, let's do it this way, okay, because that's what it was telling us to do in the beginning. If you look at the book, it separates them into 2 fractions and ends up with 2 minus 2 over 3i. Now here we're going to split it up into a fraction first and see if that's going to help us or if it's going to complicate things more. Looking at this, which do you think it's going to be? Do you think it'll help us by splitting it, or do you think it will complicate things more for us? Why is it important to even consider that? Like seriously, why even think, is this going to just jack my life up? Because if it is going to ruin your day from doing this, do you want to do it? Yeah. Yes, exactly. No, you don't want to. Especially if you have an alternate method to use that will make it easier for you. So take a second and consider what your options are and which option is going to benefit you the best. In fact, when it comes down to it, which option is going to make it easier for us? Okay? So let's look at this. What if we do the i's like we talked about, 2 over 3i times I over I, plus 6i over 3i times I over I. This gives us 2i over 3i squared plus 6i squared over 3i squared. Okay? Now from here, we can substitute anywhere that there's an I squared and put a -1 in there. And by the time we're done, we're going to end up the same thing as here. Okay, so we have 2i over 3 times -1 plus 6 times -1 over 3 times -1. Okay, and we end up with this same answer. Which one was easiest for you, do you think? The second one, right? Sure. Okay. However, there may be times that you have to break it up first because of the information that you're given. So know that this is just an option that may end up being easier or maybe more complicated, but you have 2 possible ways of doing this. It doesn't matter. And then ultimately, you're still using the same method to get to your final answer. Does everybody understand the multiplying it times 1 bit? Okay, so let's look at this real quick. Let's say that negative numbers give you heartburn. The moment they come up, next thing you know, you're throwing down Pepto-Bismol because it gives you heartburn. So we have this right here, 2 plus 6i over 3i. Look at page 317, and what is an alternate form of 1 that you could choose so that you don't have to use negative numbers? Because here you multiplied it times 1 by I over I, which gives you I squared, which is negative 1.
You do negative.
Hmm?
Negative. You're doing what?
Well, you're multiplying.
You're going there.
Okay. So here we multiplied it times I over I. What's another option? Another form of 1, using one of those 4 options.
Negative 1 times negative 1?
Well, but that's not getting rid of the I. The whole point of this is to eliminate that I from the bottom.
I to the 4.
Okay, what does that result in?
Positive 1.
Positive 1. Okay, but that's what we're wanting to get to is I to the 4th. We already have an I here, so what would make it I to the 4th on the bottom? I to the what? 3rd. Okay, so you can manipulate this however you want to. So now when you multiply it out, you have 2i to the 3rd plus 6i to the 4th over 3i to the 4th. Well, then that gives you 2i to the 3rd plus 6 plus 3 times 1 times positive 1. So now you're not dealing with negative 1s. And then you simply substitute out whatever I to the 3rd equals for where it's attached to this 2. So find what fits you. If this is more complicated for you, well then scrap it. Okay, if you think, you know what, I can deal with this, I can remember this, and I'll just deal with the negative 1s, well then do that. But just know that you have options out there. You're given information and you're given sets of rules, but there's not one set way that you have to do this. Okay, it's just like, you know, unfolding a table and putting it up. You can have 2 people hold it in the air while you put the legs down. Or you can turn it on its side and open it up and then try to flip it over by yourself. You can put it on its back, flip the legs up, and then throw it in the air and then hope that it lands, you know, on its feet. There are several different ways of doing this, okay? And all of them can get the job accomplished. Okay, find out whichever way benefits you the best. What helps you to do that is understanding it. Okay? Cool? Awesome. So let's move on. Without looking, what page are your imaginary numbers options on?
317.
317. Oh yeah. Yeah, boy. Real quickly, let's look at example 2. We're not going to do this on the board. We'll look at it here in the book. Notice that now you are dividing by the square root of 6 times I. 2 things that are important to understand about this. On the square root that it's showing, it's 6 and then the I is outside of it. This square root sign does not cover the I, so pay attention to those whenever you're reading. Don't go so fast that you miss that. Because there's a big difference between this and this. Now, with that being said, notice that you're dividing by the square root of 6 times I. Here, you have to get rid of both the I and that square root, the square root symbol. So they chose this as the best option for their form of 1 to multiply it by. So that way you're getting rid of both of them at one time. Because you're multiplying the square root times the square root, and then that I times I gives you I squared, which is your -1. And then that's how they're eliminating that information, putting it in proper form on the denominator, and just changing it up. Okay? Make sense? Does everybody kind of see that on here? Okay, cool. On example number 3, notice, I'm just simply going to point out, notice that their form of 1 that they multiplied is 3 plus I over 3 plus I. All right, you have a binomial at the bottom. So you have 2 plus I divided by 3 minus I. And we're going to multiply this times 3 plus I over 3 plus I. Now I will give somebody an extra 4 points. I'll wait till Ellie gets in here. Okay? Real quick, we're looking at example number 3. Okay? And the reason why I was waiting is because I just came up with this. We're given 2 plus I over 3 minus I. Now they chose to multiply it in their form of 1 that they're multiplying to be 3 plus I over 3 plus I. Not 3 minus I, but 3 plus I. Okay, I will give the person 4 bonus points on their test, their Chapter 8 test, if they can explain why they chose this form and how it affects this denominator, why they chose that specifically. If you can name me the concept. Go ahead. Well, no.
That would be a negative.
Negative times a positive is a negative. That's true.
Because they want to get rid of the negative?
There is a specific reason think about when multiplying binomials. There's a shortcut. I will give you that hint. If you can name what that shortcut that you can identify something as, go ahead.
FOIL method?
What's that?
Like to use the FOIL method?
Well, you do, but you won't have to use the FOIL method if you know this shortcut.
Conjugate of the divisor?
Nope. That's what's taking place. I chose not to use those big words. But yes, that's correct. But there is a reason why. There is a shortcut that we've talked about in the past.
Can we factor the bottom one out on all the top ones to simplify it?
Ultimately, you're going to be able to, but there is a reason why they chose this, and it's specific to this right here. It's the relationship between this and this, to where they have to actually use less calculation because you can identify it as a shortcut. I'll give y'all 10 more seconds. Go ahead.
Reciprocals?
Nope.
Is it because that turned into a 1?
Well, it is 1,
Yeah.
but that's part of it.
Yeah.
But why did they choose this form of 1?
Because the i's go to the second, and then it'll times against the 3, and that cancels it out. There's no word.
Yes? No? 5, 4, 3, 2.
they'll add, like, once it's all done, it'll end up being 10 on the bottom. And it'll end up getting rid of the I on the bottom.
Well, ultimately you will. That's the whole reason for doing this. We're doing this to get rid of the bottom. So, have you heard of the term completing the square? Or no, let me back that up. It is the difference of squares, is what I meant to say. Difference of squares. Okay? So whenever you have this, and the same thing, but it's a positive, what can you, without doing any calculation, end up seeing on this? What can it end up being? Okay, everybody write this down. This is going to be part of your homework assignment. Difference of squares. You will need to, and this is a requirement, okay? In fact, I want this to be added to your Chapter 8 test. Somewhere on your Chapter 8 test, this must be done. To define or give an explanation of difference of squares, and then give me an example. There's plenty of them in the book. But look them up, find them, and then go back, because this is very, very useful. Whenever it happens, it saves you a lot of time. Yes?
Would it be negative, or 3 minus I squared, or I squared?
No, but you're close. You are very, very close. Anyway, look that up, okay? And then we'll move on. So anyway, now, as you can see in the book, that they end up with 9 minus I squared on the bottom. And so now you have 9. We're just looking at the bottom. 9 minus I squared. Well, I squared equals -1. So now you have 9 minus a -1, or 9 plus 1, which equals 10. You ended up with 10 on the bottom. But it's simply because they chose this form specifically because there's a shortcut that exists when multiplying two binomials. It's the difference of squares. Okay? 8.5. Quadratic equations. Now, y'all remember quadratic equations? Remember? Yes. They're awesome. Yes. Especially whenever you quadratic equations, you have it's ax squared plus bx plus c equals 0. Or say 2x squared plus 4x plus 8 equals 0. And that's not an accurate one, but just to show an example. Okay, we've seen this form. We factor this into two sections, and we find out what inside of here that it should be for x that makes this 0, makes this a true statement. Okay? With that is if you look at the top of page 334, you have the quadratic formula that you can use, and you simply identify, like on this one, A equals 2, B equals 4, and C equals 8. Okay? If we were given this, we see that A is 2, 4 is in the B spot, and 8 is in the C spot. Well, then on the quadratic formula on the top of page 334, all we do is substitute the 4 in for wherever we see a B, the 2 in wherever we see an A, and the 8 wherever we see a C. And then calculate it up. It's easy because some of them are more difficult to have to factor and go through that method. So this is the catch-all. This is, no matter what you have, this formula will work. Okay? Now, what we're going to focus on this, though, is the radicand. Okay? This part, b squared minus 4ac, sorry. The part that is inside here, b minus 4ac. Okay, we're focusing on this part right there. Now, what will happen is, with this, what we can do is find out the value when we plug it in here. So let's do that real quick. We have b squared, so it's 4 squared, minus 4 times 2 times 8. So we have 16 minus 8 times 8 is 64, which equals 48. Negative 48, sorry. Okay, so all we got to do, we're given one of these. We identify what's A, what's B, what's C, and then we plug it into this right here. And then we find out what our number is. That's pretty easy. You can use a calculator, that's okay. I don't mind. Now what we're going to do is take this information and look at the top of page 335. Here you have one of 3 options to assist you with your homework. If your answer is greater than 0, then there are 2 real solutions. Okay? 2 real solutions. If it is equal to 0, then there is 1 real solution. If it is less than 0, which this is, then there are 2 imaginary solutions. 2 imaginary solutions. Okay, so on your homework assignment, it says give the value of the discriminant, and the discriminant is this right here. Okay, both of those, the value. So you'll give that answer, then you'll look up there, which one is it, and it'll ask for how many solutions do you have. There are 2, and they're imaginary solutions. Okay, now what it's going to say, if you look in the paragraph below that chart, it says if D is a perfect square, both of those solutions are rational solutions. Okay, if D is a perfect square, then both of those solutions are rational solutions. If it is not a perfect square, then both of those solutions are irrational. So on your homework assignment for this, it's asking you for a 3-part question. What is the value of the discriminant? How many possible solutions are they? And is it rational or irrational? Is negative 48 a perfect square? Everybody shake your head back and forth. No, it's not. Okay, so it's irrational. The answer will be irrational for this. And then you go through and do all of them. So let's do this real quick. Actually, I'm kind of running out of time. Does anybody have any questions about this? It's just simply plugging in numbers. Okay, finding out your value, look at your chart to find your answers, and then read that paragraph underneath it to find out if it's rational or irrational. Rational if it's a perfect square, irrational if it's not. All right, real quickly, let's go to the next section. We're going to cover 8.6 and 8.7 together. We're going to be talking about graphing complex numbers. We're going to graph them using what looks exactly like the Cartesian plane. Here we have 4 plus 6i. This is the horizontal, or the x. This is the vertical, or the y value. So if we're going to plot this point, this will be to the right, 1, 2, 3, 4, and positive 6. 1, 2, 3, 4, 5, 6. And that's it. That's really easy, right? If this were minus 4 and minus 2i, well then it would be 1, 2, 3, 4, and then 1, 2, it would be down here. This is minus 4, minus 2i. Easy enough? So you can plot the mess out of those. That's really simple, and that's all there is to that. Now, with that, you can find the distance from the origin to here. Okay? This is called the slope. The slope. Do you remember how to find the slope? M. Anybody remember?
Isn't it m equals y to the second minus y to the second y minus the first y
Mhm.
and x on the bottom.
Yep, the second y minus the first y point or coordinate, and so on. So with this one, we have 4 plus 6i. Okay, so here is your x value, that's your y value. So basically you have 6 minus 0, because of the origin being the other one, over 4 minus 0, which is 6/4, or 3 over 2, and that's the slope. Now, if this were offset somewhere, like you were trying to find the slope between these 2 points, if they were connected, then you would do the same thing. You have your x, it would be, here you have your x and your y. You would have 4 minus 4. I'm sorry, yeah, let me back up. You have 6 minus -2, and 4 minus -4, and then you can find your slope between these 2 points. Now, with that, we have what's called vectors. And if you turn, we're at 8.7 right now. You'll see examples of vectors. A vector is essentially this line showing some point of origination, and it's going out. So if 4 plus 6i as a vector, you would see this symbol, it's a half arrow up top. And you have 2 points on the vector. One is called the initial point, and that's the point at which it begins. Think of it as a ray. For those of you that have taken geometry, if you have ray AB, you have this. So you have a point that it begins at, and then you have what's called a terminal point. Even though it carries on, that terminal point is that coordinate point that it's going to. Now, within this section, it's going to ask you, one, to identify the vector, okay, which is self-explanatory, because you can identify each coordinate point by each of these standard forms. But then it's going to ask you to compare vectors. And it will say, identify any equivalent vectors. The only thing you need to understand about this is an equivalent vector are 2 vectors that have equal lengths, okay, equal lengths in the same direction. So basically they have the same slope and they're going in the same direction. Okay? So chances are, if you saw those on a graph, what would you think they would look like? Do you think they'd be perpendicular to each other? Do you think they'd be 2 skewed lines? Or what would they look like on a graph? If they have the same slope, going the same direction, parallel. Very good. Whenever you look at them, just visually, they would be parallel to each other. Okay, going the same direction with the same slope, they're not going to intersect each other at any given point because they have consistent slope going whatever direction, whether it's positive or negative slope. Okay? Make sense? All right. Are your noggins full, like up to here? Mine is too. Thank you very much. Very good job. If you have questions, please contact me. I mean, I can be too full. All right.